Okay, so our first problem here, again, let's take a read through it. The superintendent of a large school district wants to know what proportion of middle school students in our district are planning to attend a four-year college or university. Suppose that 80% of middle school students in our district are planning to attend a four-year college or university. What is the probability that an SRS of size 125 will give a sample proportion of, at most, 75%? So again, one of the first things you always want to do is try to figure out what we're dealing with. A sample mean or sample proportion, that's stated right there for us. Okay, so what we'll be collecting in this case is the proportion of all middle schoolers who plan to go to college. Okay, so now that we've defined that, we have a proportion. Okay, again, the same plan for every single thing. First thing we need to do is check our 10% condition. So if we go and do that, our 10% condition, are we taking less than 10% of the population? So 10 times our sample size needs to be less than or equal to the entire population. Well, 10 times 125, that gives us 1250. And if we think about it, there definitely are more than 1,250 middle schoolers. And especially in a large school district that they have. So we are good with that part there, which means we can use our standard deviation. So again, we are using this to allow us to find the standard deviation of our sampling distribution. So the standard deviation of our sampling distribution, again, is P, which is 0.8, times 1 minus P, which is 0.2, over our sample size of 125. Quick calculation gives us 0.0358. So, in our samples of size 125, we're expecting to deviate from the true mean by about 0.03, so about 3.5, almost 4%. Next thing we need to do is check that this is going to be a normal distribution. Okay, again, are we taking a large enough sample size? Since this is proportions, we will use NP and then times 1 minus P. If this was means, we'd use N is greater than 30. So NP greater than or equal to 10 and N times 1 minus P. So in this case, 0.8 times 125, okay, that is 100. So yes, that is greater than or equal to 10. 0.2 times 125, and that is going to be 25, which is greater than or equal to 10. We are good there, which just basically says our sampling distribution will now be normal. Sampling distribution of P hat is approximately normal. Our mean is going to be the 0.8 that they gave us, and the standard deviation is the 0.0358 that we found. So this process right here, this bit that we've done, is identical for almost every problem. You need to have that in your setup. Again, things that will change. Maybe instead of P, we're talking about X, and we're taking means that there with our sample means, and that would just change some of your formulas. So we get to the actual problem they're asking, what is the probability that a random sample of 125 will give us a proportion of at most 75%. Okay, so this again is the part that will change each problem. So the probability that our P hat will be at most 0.75. Change that to a z-score. And that gives us a z-score of a negative 1.3966. Again, if you use normal CDF at all, you need to make sure everything gets labeled. That is 0.081, so roughly 8%. Okay. So we go to interpret this. There is about a 8% chance a sample of 125 students will result, or in this case we'll have a proportion of at most 75% of students who want to go to a four-year college. So again, these problems are all going to be very, very similar, and all this stuff is required. So again, make sure you define a variable to start right up here. And then to use our standard deviation, we must check the 10% condition rule to find that standard deviation. Before we can go ahead and find any probability, we do need to check that it is a normal distribution and state what that distribution would then be. And then we find our probability, and anytime we find a probability, we want to make sure we interpret what that means. So these are all expected for you on your test, that you have all those parts. Another thing is, just remember in a sampling distribution for our mean here, so our mean of our sampling distribution of p hat is again equal to the population proportion, and so that's where that value comes from.